video we'll cover section 10b, operations with radicals. In the last video we talked about radicals and simplifying them. Now we're going to start adding and subtracting radicals together. Now this is actually pretty easy, this first part, because we've actually already done something very similar to this. Remember when we could only add like terms, so only x terms could be added together, only y terms could be added together. That's the same thing with radicals. Only terms with like radicals can be added together. So, like I said, we've already done this before with like x's and y's, so the same thing really is the same with radicals. So with part A, look and see where you have like terms. So I have or like radicals. So I have a radical 6, and then a radical 7, which that's not the same. So we cannot add that. So 2 radical 6 and 5 radical 6, you can add those two together, and we're going to add their coefficients, kind of like what we had with like 2x and 5x. So 2 plus 5 makes 7, so this would make 7, and then the root 6 doesn't change, just like with our like terms with x's. So it's going to be 7 root 6. So it's like I had 2 root 6's plus 5 root 6's. That makes 7 root 6's. Now the 3 root 7 is not alike, so it's just going to stay the same, and it's going to add on to the end. Here I cannot simplify this any further. Since they're not alike, we can't do anything else. Okay? So now let's try B. B, we have the square root of 10, square root of 3, it's not alike, and then another square root of 10. Now look at the coefficients, including the sign in front. So I have 3 here, and the other square root of 10, look, I have the negative 5. Don't forget that negative. So what you're doing is 3 plus negative 5, or 3 minus 5. And 3 minus 5 is negative 2. So we have negative 2 square root of 10. Then the 4 root 3 doesn't have anything else to add with, so we just add it to the end, and that's our answer. Okay, so let's keep trying for part C. All of those terms are alike. Square root of 5, square root of 5, square root of 5. So we're just going to add their coefficients together. Now notice that the middle square root of 5 doesn't have a number. It's just like our x's. If there's not a number there, then that number is understood to be 1, not 0. So we're going to add 4 plus 1 minus 2. 4 plus 1 is 5. 5 minus 2 is 3. So my answer is 3 square root of 5. All right, now in D, at first it looks like that these are not alike. However, if you look at 27, 27 is not, the square root of 27 is not a simplified square root. In all my other examples, 6, 7, 10, 5, those are all simplified square roots. They do not have any perfect squares in them. So when I get to D, however, 2 root 3 is simplified, but square root of 27 is not simplified. So before you can start adding terms together, you have to make sure that they're simplified. So 2 root 3, I'm just going to rewrite that because that's the same. But square root of 27 has the perfect square of 9 in it. So 27 is 9 times 3. So when I simplify that, you get 2 root 3 plus square root of 9 becomes 3 with root 3. Now we have like terms. We have 2 root 3 plus 3 root 3, which then would become 5 root 3. Okay, so again, that's pretty easy. We've done this before. The only thing that you would have to watch out for is simplifying before you add or subtract like terms. Okay, and that's exactly what you see in this next example, is simplifying before combining like terms. So we've already talked about that with the above example. So with square root of 20 and square root of 45, both of those have perfect squares in them. 20 has the perfect square of 4, and 45 has the perfect square of 9. So now remember how to simplify. The square root of 4 is 2. That 2 comes out of the square root. There's no more square root with the 2. The 5 stays in. Same with the 9. Square root of 9 is 3, so that's going to be 3 square root of 5. Now these are like terms, so 2 minus 3 is negative 1. We don't have to write the 1. We do have to write the negative, so that's going to end up being the negative square root of 5. All right, and now for part B, 18 and 50. They're not alike, so now check to see if there's any perfect squares in them. So 18 has the perfect square of 9 times 2, minus 50, the perfect square would be 25 times 2. So now I'm going to simplify. Square root of 9, square root of 25. Square root of 9 is 3, so the 3 in front will then multiply by the 3 for the square root of 9. 2 stays in the square root. Minus 6 times square root of 5 becomes square root of 25 becomes 5, and 2 stays in the square root. So 3 times 3 is 9, root 2. 6 times 5 would be 9 minus 30, root 2, not 5. Oh, hold on, sorry. That all deleted. There we go. So now we have perfect squares, or sorry, not perfect squares, like squares of root 2. So 9 minus 30 would be negative 21, sorry, root 2. Okay, so that's how you use your operations with your radicals. Now, this was adding and subtracting radicals, so you can only add and subtract radicals that have the same radicand, right? The same radical. So now we're going to look at, instead of adding and subtracting, we're going to look at multiplying. So we're going to look at binomials. And remember, a binomial is two terms inside parentheses, okay? So we're going to look at binomials that contain radicals. So for example 3, notice that I have the square root of 2 times square root of 2 plus square root of 5. Now, square root of 2 plus square root of 5, inside that parentheses, that cannot simplify, okay, because they're not like radicals. But what you can do is you can distribute that square root of 2 inside both of those. So then what that would look like, you would get square root of 2 times square root of 2 plus square root of 2 times square root of 5. Then you can simplify. When you multiply, you can multiply unlike radicals. Square root of 2 times square root of 2 would be square root of 4. Square root of 2 times square root of 5 would be root 10. Now those are not alike, so we cannot add those. But you do want to simplify because the square root of 4 is just 2. Square root of 10 does not simplify, so this would be 2 plus the square root of 10. So now let's try B. So B, again, root 3 minus root 2 cannot simplify. So we're going to distribute. This time I'm going to skip a step, and I'm just going to go ahead and multiply inside my radicals. So square root of 6 times root 3 is root 18, minus root 6 times root 2 is square root of 12. Now, you have to make sure that these don't simplify. 18 and 12 do simplify. So square root of 18 now becomes the square root of 9 times 2. Square root of 12 now becomes the square root of 4 times, not 2, 3. So then the square root of 9 becomes 3, root 2, minus square root of 4 becomes 2, root 3. Now, these are still not like terms, so this is actually my final answer. All right, so finally, the last example that we're going to do is what if we have a binomial times a binomial? Well, we've done this before, just not with radicals. So remember, when we multiply two binomials, we're going to do what we call double distribute. So in example 3, we were like single distributing, just the one thing. But now we're going to double distribute. All right, so remember double distribute, you take the very first thing that you see, we're going to skip over that next thing over to the next parentheses. So that 5, it will multiply by 3, giving us 15. Then the 5 is going to go over to the second thing, so 5 times 2 root 3. Now the 5 is only going to multiply, that's not a radical. So the 5 is going to multiply with the number that's not inside the radical, which is 2. So that's going to be 5 times 2, and that's a plus 10. And now the root 3 does not get the 5 because the 5 is not in the radical. So that's just going to stay root 3. So 5 times 2 is 10, then the root 3 just attaches. Just like you would if you were multiplying 5 times 2x would be 10x. The x doesn't change. So now that we've multiplied that, now for our double distribute, we're going to now multiply the negative square root of 3 times 3, and then times 2 root 3. Negative root 3 times 3, well, first of all, it's going to be negative. It's going to be subtracting. Root 3 times 3, the way we write that is we like the number not in the radical out front. So that would be 3 root 3. And then negative root 3 times 2 root 3. Now, since 3 is inside the radical, it's not going to multiply by the 2. It's going to multiply by the 3. It's also going to be negative. The 2 is not going to change. And then you multiply 3 times 3, which is going to be the square root of 9. Now, you could have also noticed that when I multiply root 3 times root 3, I taught you in the last lesson that what's going to happen is those square roots, if they're the same number, are basically going to cancel out. So, and also you can see the square root of 9 becomes 3. Either way is fine. Now we're going to look at simplifying and combining like terms. 15 has no radical with it, and neither does this because that's going to become 6. So 15 minus 6 would then become 9. And then we also have 10 root 3 minus 3 root 3. Those are like terms, so 10 minus 3 is 7. So this would be plus 7 root 3, and this would be our final answer. Okay, so for our very last problem, oh, just kidding, no, we have 2 more problems. Okay, so I'm going to erase this for A so that I can do B. All right, now notice B is squared. Now make sure you understand that this is not equal to both of those things squared. So you can't just take 4 root 2 and square it plus the square root of 3 and square it. Absolutely not. Okay? When you have a binomial that's squared, what you have to do is multiply it out. You're going to have to double distribute. So I would rewrite this as 4 root 2 plus root 3 times 4 root 2 plus root 3. And double distribute just like we did in part A. So 4 root 2 times 4 root 2. Now, what you're going to do is you're going to multiply the like terms, basically. So 4 and 4 are outside the square root, so those get multiplied to each other. So 4 times 4 is 16. Then what's inside the radical gets multiplied together. So that is square root of 2 times square root of 2, which would be square root of 4. Or you could just write times 2, since you know those square roots are going to cancel out in this case. Okay? Then 4 root 2 times root 3. So again, you're multiplying the outer numbers, which here would be 4, and this number would be 1. So 4 times 1 is 4, and then the square roots multiply, so that's 2 and 3. So 2 times 3 is 6. And square root of 6 does not simplify, so we're going to leave that as square root of 6. Since 2 and 3 are not alike, you could not just cancel out the square root. All right, so next we're going to do the square root of 3, and it gets double distributed. Now it has a 1 in front of it, so the outer numbers 1 and 4 get multiplied to get 4, and then the inner numbers 3 and 2 make 6. Then last, root 3 times root 3. So root 3 times root 3, the 1 times 1 cancels or becomes just 1, and then root 3 times root 3 is just going to be 3. So now simplify. 16 times 2, we know that that's going to be 32. And so 32 plus 3 is 35. Then you have 4 root 6 and 4 root 6. So 4 plus 4 is 8 root 6, and that is my final answer. All right, last one, so part C. Now, part C, I want you to notice something. Do y'all remember this? A minus B times A plus B. Hopefully you remember that as being a difference of squares. So remember, A minus B times A plus B, remember, is A squared minus B squared. Okay, so that was a difference of squares. So what you're given here is basically that format of A plus B times A minus B, where A is 4 and B is the square root of 7. So if you see that pattern, You could obviously go ahead and double distribute just like we did for A and B. But if you see that this is a difference of squares, you can go ahead and pick up on that pattern and go straight to this step. You can only do that for a difference of squares though. So A squared would be 4 squared minus B squared, which would be square root of 7 squared. So then this would just be 16 minus square root of 7 squared would just be 7, and 16 minus 7 is 9. Okay, so that's kind of a shortcut there, but like I said, if you don't recognize that difference of squares, then you could have just like double distributed, just like we did in the first two examples. All right, so that is operations with radicals.